This hidden Jupiter, the largest planet in our solar system, is home to an incredible collection of moons, but 4 stand out due to their unique characteristics: Io, Europa, Ganymede, and Callisto. These moons, known as the Galilean moons, were discovered by Galileo Galilei in 1610 and have since fascinated astronomers. Io, the innermost of the 4, is the most volcanically active object in the solar system. Its surface is constantly reshaped by massive eruptions, driven by intense gravitational interactions with Jupiter and the other moons. This extreme activity makes Io one of the most geologically dynamic places in our cosmic neighborhood. Europa, on the other hand, presents a stark contrast with its icy surface, beneath which lies strong evidence of a vast subsurface ocean, kept liquid by tidal heating, raises the possibility of extraterrestrial life, making Europa a prime target for future space exploration. Jupiter, the largest planet in the solar system, is home to 95 confirmed moons. However, despite this impressive number, most of them are small and remain relatively unknown. The majority of discussions about Jupiter's moons focus on the 4 largest ones, Io, Europa, Ganymede, and Callisto, because of their remarkable features and scientific significance. Meanwhile, the smaller moons, though numerous, are less studied and discussed. One fascinating fact about Jupiter's moons is that their total mass combined accounts for only 0.003% of Jupiter's total mass. Even the largest of them, Ganymede, which surpasses Mercury in size, makes up only a tiny fraction of the planet's overall bulk. This highlights Jupiter's immense gravitational dominance and the relatively minor contribution of its moons in terms of mass. Jupiter's moons can be classified into 2 main types: regular and irregular moons. Regular moons are those that formed naturally within the protoplanetary disk that once surrounded Jupiter. These moons follow nearly circular orbits and move in alignment with Jupiter's equator. The 4 Galilean moons belong to this category, along with a few smaller inner moons. Irregular moons, on the other hand, are believed to be objects that were captured by Jupiter's gravity from other parts of the solar system. They typically have highly tilted, elongated orbits and often move in a retrograde direction, opposite to Jupiter's rotation. Most of these moons are small, with diameters of only a few kilometers, making them difficult to study in detail. Regular moons of Jupiter are natural satellites that formed from the planet's original protoplanetary disk. This disk was made of gas and dust that surrounded Jupiter during its early formation. Over time, some of this material coalesced into moons that now follow stable, nearly circular orbits around the planet's equator. These moons tend to be positioned relatively close to Jupiter compared to the irregular moons, which have more erratic orbits. Jupiter has 8 known regular moons, with the 4 largest, Io, Europa, Ganymede, and Callisto, being the most famous. These Galilean moons were discovered by Galileo Galilei in 1610 and remain some of the most scientifically intriguing objects in the solar system. In addition to the Galilean moons, there are 4 much smaller regular moons located closer to Jupiter. These inner moons, Metis, Adrastea, Amalthea, and Thebe, help shape Jupiter's faint ring system by supplying material from their surfaces. Although regular moons generally form naturally from the surrounding disk of material, some scientists believe that certain moons may have been captured rather than forming in place. If a celestial body was pulled in by Jupiter's immense gravity and settled into a stable, circular orbit around its equator, it could resemble a regular moon despite having an external origin. However, such cases are rare, and most regular moons are thought to have formed alongside Jupiter, remaining in predictable and well-defined orbits ever since. Irregular moons of Jupiter are natural satellites that orbit at great distances from the planet, far beyond the orbit of Callisto, the outermost of the 4 largest moons. Unlike regular moons, which have nearly circular orbits aligned with Jupiter's equator, irregular moons follow highly inclined, elongated, and sometimes eccentric paths. Their orbits suggest that they were not formed from Jupiter's original protoplanetary disk, but were instead captured by the planet's immense gravitational pull. Jupiter currently has 87 confirmed irregular moons. Of these, 74 exhibit retrograde motion, meaning they orbit in the direction opposite to Jupiter's rotation. This retrograde motion further supports the idea that these moons were once independent celestial objects, such as asteroids or Kuiper belt fragments, that drifted too close to Jupiter and were pulled into its gravitational influence. The remaining irregular moons, though fewer in number, have prograde orbits, meaning they move in the same direction as Jupiter's rotation. Irregular moons are typically much smaller than Jupiter's major moons, often measuring only a few kilometers in diameter. They are thought to have formed elsewhere in the solar system before being captured. Some of these moons are grouped into families based on similarities in their orbits and compositions, suggesting they may have originated from larger parent bodies that broke apart due to past collisions. These moons provide valuable insight into Jupiter's gravitational influence and the history of planetary formation. The most distant irregular moons of Jupiter follow highly elongated and inclined orbits, setting them apart from the planet's closer, more regular satellites. Among them, Calm holds the record as the most distant known moon, orbiting Jupiter at an astonishing distance of 24.2 million kilometers. However, some irregular moons travel even farther at certain points in their orbits, reaching distances of up to 31.5 million kilometers from the planet. These moons take an exceptionally long time to complete a single orbit around Jupiter. Unlike the planet's inner moons, which complete their orbits in days, the most distant irregular moons can take nearly 2 years to travel around Jupiter. This period is comparable to the time it takes for Mars to complete one revolution around the Sun. Their long orbital periods and extreme distances make them difficult to observe, and many were only discovered in recent decades thanks to advancements in telescope technology. Because of their highly eccentric orbits, these moons experience significant variations in distance from Jupiter. At their closest approach, periapsis, they may be tens of millions of kilometers closer to the planet than at their farthest point, apoapsis. Their unusual orbits provide further evidence that these moons were not originally formed alongside Jupiter, but were instead captured from the surrounding space. Studying these distant moons helps astronomers understand the complex gravitational interactions that shape Jupiter's vast moon system. While 95 moons have been officially confirmed orbiting Jupiter, the true number could be significantly larger. Some astronomers estimate that Jupiter may have hundreds of small moons, many of which are less than 1 kilometer in diameter. These tiny moons are difficult to detect with current technology because of their faintness and the vast distances involved. However, ongoing improvements in telescopes and observational techniques may reveal many more moons in the future. Jupiter's immense gravitational influence extends far into space, forming what is known as its Hill sphere. This region, which stretches approximately 53 million kilometers from the planet, marks the outer boundary where Jupiter's gravity can still dominate over the Sun's influence. Within this vast area, there is potential for many more undiscovered moons, possibly in irregular orbits far beyond the known ones. The search for these additional moons is challenging due to their small sizes and faint reflections of sunlight. However, astronomers have already found clusters of tiny irregular moons, suggesting that they may exist. The discovery of such objects could provide new insights into the processes of moon formation and capture, as well as the overall history of Jupiter's interactions with other celestial bodies in the solar system. If future studies confirm a much higher number of moons, Jupiter's status as the planet with the largest number of natural satellites will become even more impressive. One of the most notable groups is the Pacific group, moon groups based on orbital characteristics. Jupiter's many moons can be categorized into distinct groups based on their distance from the planet, orbital patterns, and surface colors. These groupings help astronomers understand the history and formation of these natural satellites, revealing clues about Jupiter's interactions with other celestial bodies. Consisting of 18 irregular moons, these moons are believed to have been captured from different regions of the solar system, as they exhibit diverse compositions and orbital characteristics. Their irregular inclined orbits suggest that they were once independent celestial objects before being pulled in by Jupiter's strong gravity. The Calm group is larger, containing around 30 moons. Unlike the Pacific group, these moons share highly similar orbits and surface colors, suggesting they originated from a single parent body that was shattered by an impact. This hypothesis is supported by their retrograde motion, meaning they orbit in the opposite direction of Jupiter's rotation. The Ananke group has a less certain origin. While these moons also follow retrograde orbits, their characteristics are more varied than those of the Calm group, making it unclear whether they formed from a single impact or multiple capture events. The Himalaya group includes some of Jupiter's largest irregular moons, such as Himalaya, which measures approximately 140 kilometers in diameter. These moons follow prograde orbits and are closer to Jupiter compared to the other irregular groups. Finally, Themisto is unique among Jupiter's moons. Unlike the grouped moons, it orbits in isolation, far from both the inner regular moons and the distant irregular ones. This solitary nature makes Themisto a particularly intriguing object for study. Lesser known. Regular moons. Besides the 4 major moons, Jupiter has several smaller regular moons that play unique roles in its system. These moons, though less famous, contribute significantly to Jupiter's rings and overall structure. One such moon is Thebe, which has a diameter of about 100 kilometers. One of its most prominent features is a massive 40-kilometer wide crater, suggesting it has endured significant impacts over time. Unlike some of Jupiter's inner moons, Thebes' orbit is slightly inclined, making it stand out from the more equatorial paths of other regular moons. It also plays a role in maintaining Jupiter's faint outer rings by contributing dust and debris through surface erosion caused by micrometeorite impacts. Amalthea, the fifth largest moon of Jupiter, is particularly intriguing due to the presence of hydrated minerals on its surface. This discovery suggests that Amalthea may have formed farther from Jupiter and later migrated inward. Its irregular, elongated shape and reddish color make it visually distinct among Jupiter's moons. Amalthea also emits more heat than it receives from the Sun, possibly due to Jupiter's intense radiation heating its surface. Two of the smallest regular moons, Adrastea and Metis, are the closest known moons to Jupiter. They orbit so near the gas giant that they lie within the planet's main ring system. Scientists believe that these moons not only interact with the rings but also help shape them, likely pulling in material from the rings onto their surfaces while also supplying new dust to sustain Jupiter's ring system. Their proximity to Jupiter means they experience extreme gravitational forces, which could eventually lead to their gradual spiraling toward the planet. Future exploration of Jupiter's moons. Jupiter's moons have long been a subject of fascination for astronomers and space agencies. While missions like NASA's Europa Clipper and ESA's JUICE, Jupiter Icy Moons Explorer, are set to explore major moons such as Europa and Ganymede, the smaller and more distant moons of Jupiter are unlikely to receive the same level of attention for the foreseeable future. The primary reason is the scientific and resource-based prioritization of exploration efforts. Europa, for example, has strong evidence of a subsurface ocean that could harbor life, making it a top priority for study. Similarly, Ganymede, as the largest moon in the solar system, is of interest due to its unique magnetic field and potential for hidden water beneath its icy crust. Meanwhile, Callisto is notable for its heavily cratered surface, providing a glimpse into the early solar system's history. These moons offer valuable insights into planetary formation, habitability, and the potential for extraterrestrial life, making them the main targets for upcoming missions. In contrast, smaller irregular moons, while scientifically interesting, do not present the same immediate research potential. Their distant orbits, small sizes, and lack of significant geological activity make them lower priorities for expensive, high-risk exploration missions. However, as space technology advances, future telescopes and spacecraft may allow for remote observations and new discoveries of these lesser-known moons. For now, while more moons may be found, in-depth exploration of Jupiter's smaller moons will likely remain a challenge for decades, if not centuries.